let's dig into the artificial, I would say, intelligence neural world. So what we are seeing is artificial intelligence is a superset of everything, concerning, I would say, related to machine, mimic, cognitive capability like human. So each time we are trying to copy or to have a mimic of human stuff, so it's in a big category of artificial intelligence. So, okay, it's covering everything. Everybody's talking about artificial intelligence. It gives you possibility to have some interaction with the environment, knowledge, perception, learning, and so on. These are the keywords we are learning. And these concepts are coming from computer science. So you need science, mathematics, statistics. Okay, these are the three stuff. But this is a superset. And inside the artificial intelligence, you have one of the subset is called machine learning. Machine learning then means that, okay, you will collect a lot of data set in this case, and then you will start to train based on this data set to I will say, extract some information in order to learn and to have some, prediction in this case. So this is machine learning. So the machine will learn, in this case, you will use a machine to learn and to train your stuff. So it could be mathematics, it could be statistic, it could be, and I will show you some example. And inside the machine learning, what can we do? We have some pattern recognition. This has a keyword. We have some anomaly recognition, some prediction in the future. So it could be, stock price in the future, advertisement, and so on. Anomaly recognition. You have some machine, and then someone is trying to change the machine. You can recognize it. So this was okay. Bank are doing and other stuff, and also pattern recognition, trying to spoken word, facial identity, and so on. That's the key. You have three different kind of learning stuff in the machine learning. So you have the supervised, the unsupervised, and reinforcement. These are three techniques they have. One of the technique, and this is the one, is a supervised. So that means you will have data which are labeled. What does it mean? So if you want to recognize, I don't know, difference between the different animals, so we'll put picture with cat, and you will label it as cat. You will put picture with dog or with other animal, and then you will label all this data. So big job to be done. So that means you have to prepare this data, and then you will start to have a learning process. So you will learn from this data, and then you will try to, based on different algorithms, based on different technique. I will explain this different technique after all. And the goal of this, after this learning, is to recognize. So this is one of the method. Second method is, we say, reinforcement. So you are showing stuff, and like I would say, dressing a dog. So if it's good, if the result is good, then you have giving in sugar or something which is good, and otherwise you understand. So it's a kind of what we say, it's a rewarding system. So we are rewarding, and you are learning. So your system is learning based on that. And the third one is unsupervised. So there is no control, there is no label. So you are trying to, on the fly, to have some category, and then after all, to decide what to do. The good thing is you can have a mix of this. So these are the big models. So this is triangle, but the learning is something in between. So you can use part of it and then mix. Okay, but this is a general stuff for machine learning. And within this machine learning, what we have is some of the approach. You have much more approach, but okay, these are the main approach, we found. So the first one is a decision tree learning. So decision tree, okay, we have the picture here, so it's quite clear. Based on the data set you got, then you are trying to extract some, feature, and then try to, I will say, and the machine is trying to transfer it inside, decision tree, if, then, else, and so on. Okay, this is one of the technique. Second technique is clustering. So trying to put, all the data inside clustering, and then trying to find the area where those clusters are to predict the next stuff. So this is a method based on statistic also and mathematical stuff. We have rules-based learning. So this is something different. We have inductive logic programming, Prolog. You can have a look on the web. So it's different kind of things, mixing statistic and mathematical phenomena. And the last one, and this is the one we have interest today, is called deep learning, and using neural network in this case. Deep learning neural network, so this kind of stuff. And this is where we are focused. But deep learning is, again, a subsystem from machine learning. Okay, at ST, we are also using decision tree learning and clustering. So we also have algorithm on our sensors. So we have sensors, for instance, which are embedding some decision tree learning. So inside. So this is AI, of course. We are calling it AI. This is machine learning, but in this case, it's not neural network. Now we will dig it a little bit more inside this part. Deep learning neural network. Why? And this is why we are explaining this. Because what we have seen in neural network deep learning is existing since a long time. It was going up and down because of resources we had, because of the performances, the data set we are able to collect. Why? Because we have some advantages of the deep learning and disadvantages. What we are saying is not it's ideal for everything. So at the end, what you will realize during if you have no experience on the AI from now, so you will have to try maybe all of this and then select the best for you at a T time, and then maybe we'll change based on the amount of data you will have, based on the accuracy you need, and so on. So what we are not saying is, okay, this is the ultimative. No, this is one of them, and this is one which is quite complicated normally to port on the microcontroller. For this one, you already have some, we say, software which are existing on the web, which are converting, this in C code. So this is existing, but for this one, there was from now nothing or not so much, and it's the reason why we are concentrating on this one. What are the advantages of this one, of the deep learning? Is there? Advantages is, okay, high accuracy, and what we are saying is, okay, you have the performances and you have the amount of data. And at the beginning, I would say, let's say, that the normal algorithm, decision tree, clustering, rules-based learning, and other stuff are more efficient than the deep learning, because deep learning is quite complicated to put in place. It's requesting high computation and so on. So these are the disadvantages. But at the beginning, okay, you will see advantages of other algorithms. And then there is a breaking event, so it depends on the application. Question is when it's happening. Okay, it depends on the amount of applications, depends on the complexity of your application. But then you have a break event, and then the deep learning is continuing, to bring you some performances where the standard learning algorithm are stopping somehow. Why stopping? Because with the decision tree, it's the amount of memory space you have in this case. So somehow, each time, for instance, you're getting new data, you will change completely the structure of the tree. So it could be difficult to qualify in some case, depend on what you have, and so on. So disadvantages is you need a large data set to start. So when I say large, it's really large. I mean, it's a big amount of data to record. Disadvantages is a weak theoretical explanation. So it still look like a black box in most of the case. It's running. I have a customer. We were working 5 years long on algorithm, trying to detect some characteristic, doing some kind of predictive maintenance based on the audio. Spend 5 years, develop algorithm based on mathematical stuff. And at the end, they get something which were almost working, let's say. So it was working, was recognizing what they want. And then some condition change in the room, and then everything was gone. So all the 5 years was not working anymore, so they had to rechange and all the stuff. And okay, it was a lot of job. And then they engaged 2 AI guys and to try to use a neural network in this case. And this guy had a success after 2 months, really first success. And it was so successfully that okay, within the 2 months, they achieved to have at least at the same level at the 5 years development before and more, because then there was not big impact about the change in the environment. So they are really, but the big issue they had was to explain it, because it was safety based in this case. So they had to explain it to the final customer, and they were not able. So they had a good algorithm which were working well, but there were problem to explain why it was working so good in this case. Yeah, it could be the problem. So this is the disadvantages. We have to put it also in the balance. So what we are saying is not obvious that okay, this will be the right algorithm for you in each time and each. It's the reason why most of the people and the partner are talking about machine learning in this case, because they are proposing different algorithm, which is okay in this case. Yeah. Other comparison. okay, to be honest, these are the problems, I mean, in the AI since the beginning. So problem of object classification, so which are object, we are showing some object classification. In this case, scene classification, audio scene or other stuff. Object detection, you are putting some 1000 object, different object or more, and then you have to detect it. And then you have some data set which are on the web. So you can download all this big data set, and then you can leave your algorithm running. And these are the best accuracy you got without using the conventional, I mean, we say neural network in this case. So, and okay, for some of them it was quite good. I mean, in this case, face recognition 96.3, so quite good with conventional stuff. For some other, it was okay. And on the right-hand side, you have the best accuracy using the neural network. And then you see some plus. In some case, you have some plus, big plus, and some case not big plus. So it's not obvious again. So it's really depending on what you are doing, what you plan to do. This is the message. But in some cases, it's broke so much that some of the people said, okay, we'll not use any more conventional stuff, depending on the, the problem you had. We'll use no CNN, and they are focusing on the neural network stuff.
Machine learning, the reason why. This is the example, the written characters recognition. This is the one of the basic example of the good approach for the neural networks. It would be very difficult to develop the algorithm for that. The neural network approach for this is a very good solution in terms of the time of the development and in terms of the accuracy. Is it the cutting edge technology? Of course not. The first neuron model has been invented in 1943 in US. And the first implementation, the first only hardware implementation of the neural network has been implemented in 1957 in US as well. It was the application for the image recognition using light sensors, and the resolution of the, let's say, camera, it was 20 to 20 pixels. And the structure of the neural network was very simple. It was only one layer of the neurons. And now, this idea is still in usage. It is so-called multi-layer perceptron, and this solution is very good for the time series prediction. For example, the neural network which is able to count 1, 2, 3, 4, etc. We can put the series like 2, 3, 4, and then neural network can continue. But it will not continue like 5, 6, 7, but 4.97, 5.90 something, because this is a prediction of the time series. Okay, let's come back to school. I think all of you remember well this structure. This is the biological neuron. So we have cell body, we have dendrites and axon terminal. And dendrites are the equivalent of the neuron inputs. Cell body is equivalent of our processor, and axon, it is our output. And one of the most important message to you: neural networks, it is not digital world. We cannot say about that the prediction is 100% sure or 100% not sure. We can discuss about the probability of the prediction between 0 and 1. That's I think the most important point, the most important message. And there is no clear border to judge if the particular accuracy of the prediction is good or not. It depends on the developer and it depends on the application. So I cannot say that the prediction, that the accuracy of the neural network, which is, I don't know, 0.95 is okay. Depends on application. Okay, so this is the biology, this is the real life, and this is the mathematical model of the neuron. We have inputs, and to each input we can fit the floating point number, the value. We have set of coefficients, W1 down to Wn. Those coefficients are so-called weights in neural networks. So to each input of the neuron, it is assigned the weight, and it is also floating point number. Then we have cell body, our processor. So we need to multiply what is the function of the cell body of the processor. We need to multiply each input value by the coefficient, the weight, and then accumulate all the results of the multiplication. So another key message for you: multiply and accumulate. So the basic operation behind the neural networks. Okay, so we are multiplying input values by weights, then accumulating the results. Then we have kind of bias, just another sum. And then we are comparing the output, the result of multiply and accumulation process, to activation function. And this is the most simple activation function. So if the result is lower than 0, the output is 0. If the result is equal or greater than 0, the result is 1. So this activation function is so-called unit step. So this is the mathematical model of the neural network. And now let's see what is the possible bridge between the biology and the quite, or I would say, very useful technical implementation of neural network structure. This is the Limulus crab. This is the Latin name. The second name is horseshoe crab. And this crab has 5 or 7 eyes, the black dots on the picture. And this eye is so-called compound eye. Compound means matrix eye. And this is the structure of the one light sensor. Be another example of compound eye, and the silicon implementation of the compound eye. As you probably know, just after our eyes, we have eye nerve, and it is crossed. And do you know what is the estimated stream we acquire per second in bits in front of our eyes? It is 10 in power of 9 bits per second. So quite a lot. And thanks to this crossed eye nerve pre-processing, our brain must process only several bits per second. And this is the example or the simplified implementation of the eye nerve of this Limulus crab. This triangle, it is a symbol of the neuron. So we have 3 inputs and following weights: minus 0.5, then 1, then minus 0.5, and this is the bias. In our case, it can be considered as a threshold. So 2 of the sensors are exposed to the daylight, and 2 of sensors are exposed to the shadow. And here is the border of shadow and daylight. Let's consider this, the first neuron. This input is activated, so 1 multiplied by minus 0.5, plus 1 multiplied by 1, plus 1 multiplied by minus 0.5. So the result is 0. The result of accumulation is 0, and it is less than 0.25, so the output is 0. And for this neuron, we can do the same evaluation of the output. We have 1, and then 0 and 0. What is the conclusion? Crab exposed to the full daylight can see nothing. And it makes sense from the biological point of view, because the brain of crab is quite small, so there is no need for crab to see the landscape. But crab, thanks to this nerve eye, can very easily detect the border between shadow and light. Crab can easily count the objects. Crab can easily detect the edges, which makes sense from biological point of view. And of course, if exposed to the shadow, to the night, to the darkness, crab can see nothing as well. And this structure just reduced the amount of information and lets us to extract some features, like moving objects, like edges. And this structure, this neural network, is so-called side breaking, because the side weights are negative. That's why the side inputs are breaking somehow the activation of the neuron. And this structure is used for computer vision, for image recognition. We just discussed the atomic neuron model. But today we are talking about neural networks. And this is the basic structure of the neural network. The neural network consists of at least 3 layers. Input layer, hidden layer, or dense layer, depends on the wording, and the output layer. And what is very interesting, the number of the neurons, of the elements in the output layer, is equal to the number of classes to predict. Today, we will focus on and we will practice the audio or acoustic scene classification application. We will use microphone to distinguish between different acoustic scenes, like indoor, outdoor, and in vehicle. So in our case, we have 3 classes to predict. So the number of the neurons here will be equal to 3. The activation functions. We discussed the most simple unit step activation function. But in practice, of course, there is more types of activation functions, starting from unit step and the generalization of the unit step. So the unit step is vary from 0 to 1. The generalized one, so-called signum, vary from -1 to 1. Then linear, piecewise, logistic hyperbolic tangent, and I think quite well known to us as electronic engineers, characteristic rectified linear unit, so just a diode characteristic. And this activation function is very useful for the image recognition. Our reality is not linear, that's why we need not linear activation function for the image recognition neural network. Today we will focus on the supervised learning. It means that we need supervisor, we need teacher. And in our case, this teacher, it is of course the algorithm. What is the basic idea behind the learning process? It is so-called forward propagation. We are feeding the network with the batch of input data. Then we are analyzing, we are comparing the output on the neural network, which is so-called result of the inference, or just the inference. So the prediction means inference. We are comparing the result of the prediction to the expected value. And then, if it is not in line, the teacher, in our case the algorithm, tunes the coefficients inside the neural network. And in our case, the coefficients are the weights and the biases. And this is very complex process in terms of mathematics behind. This is the problem of the optimization of the multivariables functions. In fact, we need to find the minimum of the loss function. I will explain later on, and do it step by step. But do not worry, those algorithms are ready, the libraries are ready, and we can just reuse the ready solutions. So the teacher algorithm job is just feedback, feeding the inputs with batch of data, then comparing the output to the expected output, and then adjusting the weights. And again, the new wording. So the prediction in neural networks means inference. The expected value of the prediction of the inference, it is grand true data set. Is it clear? We are touching the surface only, I am fully aware, but we need to catch the basic idea. For the supervised learning process, we need a teacher, we need a dedicated algorithm to tune the coefficients, the weights and biases. Our solution, Cube.AI tool, supports Cortex M4 and Cortex M7 because of floating point unit, because of the hardware acceleration of the computation. Next important message to you. The neural network, the design of the neural network and the learning of the neural network, it is, I would say, this is 10%, 5% of the process. I think there are two very difficult parts. The dataset collection, it could be very expensive process, and the pre-processing stage. Because it is better to avoid feeding the neural network with raw data. I think almost always we need the pre-processing stage, which is not trivial, as you will see today. And this is for the R&D managers message. You need really experienced DSP experts in your team. This is important stage, quite time-consuming, and when it is time-consuming, it means that it is expensive. We discuss the most simple structure of the neural network, but of course, in practice, we have a lot of standard neural networks types, starting from perceptron. So do you remember the 1957, the hardware implementation? Then we can simulate, for example, long short-term memory just by implementing the feedback. We can implement some recurrent neural network structures, again, to simulate some memory process, to be able to predict time series, like stock exchange, for example. And very practical structure in terms of industry. Convolutional network. So this is the most common structure which is used for the image recognition. And the structure of this network reflects the functionality, because we have inputs, then this triangle structure, it is filtering stage. Here we are reducing the amount of data. Do you remember our iNerve, which reduced the amount of data from 10 in power of 9 bits per second down to several bits per second. So this is the role of the convolution, filtering of the data. And we can also describe this stage as a feature extraction. So the convolution layers can be used to extract the features like particular grayscale of particular areas of image, the edges, counting of the points, etc. Then we have brain of our neural network, so it is dense layer or dense layers. Dense means that the input of the following layer is connected to each output of the previous layer. And then we have output layer, and the number of the neurons is equal to the number of classes, number of states of the system to predict. Deconvolutional network. So here we have convolution, here we have deconvolution. Sometimes it seems to us that we have not so much data, but using deconvolution, we can try to find hidden patterns. please take your boards. This board, it is discovery board, so-called IoT. IoT because the main purpose of this board is to support development process of the cloud connectivity. This board is quite rich of the connectivity peripherals like Wi-Fi, sub-gigahertz, Bluetooth, and it is equipped with a lot of sensors. The MEMS sensors like accelerator, magnetometer, temperature sensor, humidity, pressure, and proximity sensor. So we have laser on board as well. But today, and the microcontroller on the top is the STM32L475. It is a Cortex M4 microcontroller from low power family. And today, starting from this lab, we will focus on the real neural network implementation. It will be audio or acoustic scene classification. We will be we'll try to distinguish between three classes, three states. Indoor, what means in meeting room, in apartment, in shop, or similar. Outdoor, which means on the street, in the forest, in the field, wherever. And in vehicle, which means in car, in tram, in train. As an input, we will use MEMS microphone. It is clear? And this application comes from our function pack. Function pack, again, it is in the wording of ST, it is set of not trivial examples which simulates the real use case of customer application. And such an example can help you very much to start the development process. And in our case, it is really not trivial because this application is FreeRTOS based. There is Bluetooth connectivity. There is dedicated custom bootloader and possibility to update the firmware over the air. There is USB mass storage profile and interface to sensors. In this case, it will be microphone, as I mentioned. I would like to highlight that we have custom bootloader in this application and the application itself. And there is quite important consequence behind because the custom bootloader is allocated to the particular area of the memory, flash memory, and the application is allocated to the different area of the flash memory. What means that we cannot use to update the application from the IDE level like TrueStudio, Keylot or whatever. We cannot download the application. We need to use external script and ST-Link utility. So this is our programmer or debugger software to download, to flash custom bootloader to particular area of memory and then flash application itself. But now we'll start from very basic, and we will we'll use this script during last lab 4. But now we'll start from very simple flashing and playing. So we have 25 minutes to the break. I think it is quite enough. Okay, let's start. Let's take your board and one micro USB cable and connect the USB cable to the ST-Link micro USB port. It is located close to the white ceramic antenna, the bigger one, ceramic antenna here. So this is sub-gigahertz radio module, like this, close to the red LED. Okay? Then please start STM32Cube programmer. The next step. Now we need our binary, because we'll just flash. This is the image of the flash memory, the dump of the memory. So we have custom bootloader and the application as a one binary file. So you need to go to this folder, C/AI/FPAI sensing 1, then projects, then BL475, applications, sensing, binary, and please select sensing 1_BL. BL means bootloader. Of course, before, sorry for I didn't mention, you need to connect to your board using ST-Link resource and open and select this tab, open file, and then go to the folder. If you open the binary file, just to remind you, sensing 1_BL. Please do not mix this file with sensing1.bin. We need bootloader. We can go further and then download the binary here in the area of upper right corner. And then when you get the file download complete, please press disconnect. I will do it as well. Okay, when downloaded, please open terminal. I suggest to use teraterm. We need breaks between characters. So now we'll connect to the virtual COM port of the ST-Link debugger on the top of the board. This is the functionality, one of the functionality of our ST-Link debugger. And this virtual COM port is connected to the UART of the microcontroller and is acting as a debug output. So for the teraterm file, new connection, and please select the ST Microelectronics virtual COM port. Okay, and the communication parameters setup. Maybe I will start from font. Let's say 12. Again, setup, serial port, 115 kilobits per second, 8-bit character, without parity, and one stop bit. Okay, and then press black button. It is reset. And now we are looking for this field, the MAC number of our Bluetooth module. Do you know why? Because we need to connect to our board, not to board of our colleague. If you can see the series of FF here, please reset again your board. What we can do now, we can practice our neural network, we can try our neural network. So please take your mobile phones and start ST-BLE sensor application. Then, of course, you need to activate the Bluetooth on your mobile phone and locate your MAC address of the Bluetooth. And then select and connect. And when connected, please navigate to the screen number 4. And we have quite big over-the-air traffic We have a lot of Bluetooth modules in one room, so be patient or try to rescan if you would not be able to find. And now you can see the temperature on the first screen. It's a little bit too much, 27 degrees. And it seems it is rainy day, considering the atmospheric pressure. And I'm just navigated to the fourth screen, and I can see the output. Now we are indoor. We are indoor, and now very important point. Important message. We are indoor with the probability of 81%. The first number, it is the first class prediction probability. The first class is indoor, and the number associated is 0. ASC 0 means that we are indoor with the probability of the first column. The second column, it is the outdoor probability detection, and the third column is in vehicle. There is also vintage user interface. You can close your application. And then let me reset the screen. So edit and clear buffer. I'm resetting the board. I need to change the font. Let's say 9. Reset. Okay, there is a Linux-like prompt, and we have command line interface. For those who prefer the vintage interface, the command line interface, we can type help for the list of the commands, and the equivalent command to the mobile phone application is ASC, audio stream classification, space, start. And you can see the neural network running process again. And just to remind you, first column, it is the indoor probability, the second column, outdoor probability, and the third one, it is in-vehicle probability. And please skip first several seconds of the data acquisition, and let the application to be stabilized. I will explain you why later on, when we will go deeper into details of the pre-processing, unfortunately. Okay, we have 5 minutes to the break. So I think, yeah.
Is the model re-evaluating in real time there?
Yes, this is real time.
If you would move it, does it, because of its using the accelerometer, maybe it's in a car, increase the probability?
Yeah, well, yeah. But this application, this audio stream classification, you can start different application, human activity recognition, and then move the board. Okay, very good input. If you would like to play more, you can select the human activity recognition. It is the screen number 3 or 5, and try to simulate the walking or running or biking, but just by shaking the board. So I will stop.
So now that we have learned, I mean, what is AI, what is deep learning, neural network, a little bit more. In this case, what we can do, I mean, with different kind of machine learning, we'll dig up a little bit more in the artificial neural network, I mean, the deep learning part, and explain the position of the Cube.AI, what ST is proposing in this case, and what you will have to learn, I would say, either by yourself or using partners in this case. I think it's important to have it in mind. So these are the 5 defined steps in this case, and the first one is a capture of the data. Of course, before, and it was quite interesting from the presentation, you have to think about what you want to do. It's not, for fun in this case. So, and this is, I think, the most important part to understand the target, and then you will have to verify if you reach what you are reaching, and otherwise you will have to change. So this is part. But then once you have the idea, you have to capture the data, and capturing the data is okay. Could be okay. Just have to record something, and that's all. No, you have to take care about how you are recording the data, in which condition. So I can take I don't know the example we faced during the audio scene classification, because for the audio scene classification, so I mean the small demo you were playing with before, so we had to record hours and hours of indoors, outdoors, and in the car stuff. And at the beginning things were working well, because the room was a medium room, but then we had to try in a bigger room, then we have to try in some specific room. So that means we had to capture a lot of data and to remember in which condition we were, in order to, in case of bad training, to come back and maybe modify and change all of this. So it was important. So capturing is quite simple, but it is a basic, because if you are recording bad, I would say capturing bad information or not proper information, because you are subcontracting it and the guy is not really taking care about this, or you are recording a motor and normally the motor is like that, but I don't know, because someone cleaned the room and changed the motor and the motor is not exactly in the same position, then you will get maybe trouble. This is the first thing. Then there is also, you are capturing the data using sensors. Okay, but then in the final application, you will maybe use other sensors. So maybe there will have also discrepancies. You have to think about this. And this is important. I mean, maybe to use the sensor, the same data, the same sensor for the capture and for the final application, or maybe not to have, to stay global in this way. So these are things you have to think about. Because maybe you will record using a normal microphone, and in final application you will use a MEM sensor, which have different resonance. So really it's something you have to think about. It's not only recording the data, it's how I'm recording the data. And okay. The next step is to clean the data. So to be sure that you are not recording stuff you don't want to record in this case, or adding a noise, or adding unuseful noise. Then you have to, in the case of I would say specific learning, you have to label the data and then prepare and think about the neural network topology. And the third step is then you have to train the NN model using, as we see, a TensorFlow, using a big stuff. So for this part, for this area, there is no ST tools in this case. I will show you, because there are plenty of tools on the web. I mean, in this case, our big partners, a big name, are creating their own tools in this case. So this is something you can use. The point number 4 is then to convert it. So once you have a trained network, so that means a neural network, then you will convert it in a C code in order to be able to, to use it on the microcontroller. The 5th step is to process and analyze. I mean, see if you have any discrepancy between the theoretical model and the real model, because don't forget that you are converting in this case. So that means could be that the result is not completely 100% the result of the theoretical model. This is first of things. And then here, converting, you will maybe also want to compress, because there are also optional to compress the model in order to fit in less memory. And then you will have to check, I mean, if you are still in line. So this is also an important step. And the final one is, of course, to check if you reach what you plan to reach, which was also final 0,0. So these are the 5 identified steps we had, implementing or trying to implement a neural network into a microcontroller application. Let's go a little bit more I would say, deeper, and what ST is proposing as a tools. Okay, so we have some tools, and this is one of the tools you have on the table. Is okay, the tools we are proposing in order to, how we say, to be initiated or to start to work or to start to develop. It's maybe not the tools you will use at the end. You will maybe develop your own tools. You will maybe use tools from our partners. So again, if you are interested in tools, ask the partners, because they have also developed their own tools, and they will maybe help you with these tools. So ask them, please, in this case. But okay, to capture data, we have tools, and this is using the mobile phone in order to clean, label, and okay, and at this step you will have to think about the NN topology. So we are not helping you for the NN topology, but you have to think about the NN topology, neural network topology. For the step in the middle, as I say, there is no ST tools, because you will have to go in Python to learn Python in this case and use tools which are existing on the web. For the fourth and fifth step, so for the first step, it's a Cube.AI. So finally, the Cube.AI we are proposing is there, and this Cube.AI, which is part of the CubeMX, this option from the CubeMX is there to convert, again, like it is, to convert the code or the neural structure, the neural network structure with the white and with the structure into a C code, or we say a meta code, let's say like this. We'll present it. Okay, so that means for you a C code, and also helping you to verify if the code which were transferred, I will say, or converted, is from the reliability at the same level as the example, for instance, on a theoretical form and also on the practical form. So on the target, direct on the target, you will be able, using these tools, to check on the target if you have discrepancy between the theory and the practical model. And I think it's quite important for you, because at the end you have to have a working model, close to the theoretical. Okay, and finally, to process and analyze, so this is the board we have. So let's present the different boards we have. So we have a very small board, which are called sensor tiles, including SD cards. So we will have the possibility to put some SD card to record a lot of things. It's the one we use, for instance, for the audio scene classification, because it was small. We put it everywhere, and a lot of ST people were wearing it, and then recording a lot of stuff. It is nice. The only missing point, I mean, for us today on the workshop is there is no ST-Link. So you had normally to add an extra component. It's the reason why we did not select this port. But this port is existing. Then we have the next generation of this port, so including IoT. So this is a sensor tile.box. And this is also water resistant, and including Microsoft Azure access and so on. So much more IoT stuff. But again, with SD card, so you have the possibility to record a lot of data. And finally, this port, this is the one we have, which is quite good for IoT, which is quite good because you have the ST-Link on board, so that means you can program, you can, The only drawback for artificial intelligence, or what we are doing today, is we only have a quad SPI with 1 megabyte. So it's not so much. And for audio recording, for instance, it's roughly 1 minute of record. So it's not the best board for this kind of stuff. But okay, it's just, again, board to play with, to understand the principle. This is what we'll do today. Then if you really want to record a lot of stuff, either use a partner's board or use a board with embedded SD card on it. Okay. This slide is now, combination of sensor and STM32. So as I mentioned this morning, ST are also providing smart sensors, what we call smart sensors, so MEMS sensor, with some machine learning core embedded on it. So in this case, what you can do, so with some decision tree and machine learning with different stage, so that means you have algorithm you can learn, you have a certain amount of memory, so you can do some of the stuff, and which could be good in this case as a pre-processing. So you can, you have an accelerometer, and you want to detect if something is falling down in order to switch off the system or to protect the system or save everything. So maybe you can use this one, because in this case it's good enough in order to, to detect if something is falling down. But if you want to have something more complicated, and the good thing is, okay, consumption and so on, because everything is implemented, so you will have a less consumption, it will be on the fly, so this is something we are proposing. But then if you are combining it to a STM32 in this case, then you are adding the deep learning or neural network, in this case, stuff. Okay, and you can combine both. You can first detect if something is falling down, then switch on the STM32, and then start the neural network stuff, and then define if it's really falling down or what is happening, on which condition, what exactly happening. So you can combine both. Collecting the data and architecting NN topology. So that means is where we have, in this case, selected partners. Of course, I can help with more because I have experience about or a little bit before or after. So it's depending on the partners we have. So we have a dedicated website for AI, for STM32. And inside the website, you have a selected partner, in this case. Means that we are in communication with the partners and they're working, they have knowledge about ST in this case, and then know what they're talking about. And to clean the label and the topology, we have the Bluetooth sensor mobile phone application you already have installed and play with. And the code are open in this case, so you can find the code on the website, and then you can modify, slightly. It's giving for you as example, a start example in order to define or to develop your own application. For the training neural network model, so this is somewhere in the middle. So we mentioned already TensorFlow and Keras. So we are also compatible with TensorFlow Lite microcontroller. So TensorFlow, which is dedicated for microcontrollers, so generated structure, neural structure, which are, I would say, which fit more with microcontrollers and microprocessor in the past. So we are compatible, and there are Lasagne and Café. TensorFlow and Keras, this is more the Google in this case, and the rest is, the big name, which are known in this case. And the conversion tools I already mentioned, and then to analyze for the deep learning. This is a Cube.AI roadmap, because what we are proposing in this case, as I say, from the STM32, maybe I did not mention it to everybody, what we need for the Cube.AI is at least a Cortex M4. So Cortex M4 or Cortex M7, because we have integrated floating point unit inside, and these are the reason. Of course, we have partners. We already have algorithms which are running also on M0 and M3, because it's also possible. It's just a question of inference time, so that means accuracy and speed of the stuff. But if you are happy and if you have a simple structure, you can also do it in a small microcontroller. But for the Cube.AI at the moment is only supporting Cortex M4 and Cortex M7. Supporting floating point support since beginning of 2019. Supporting, of course, the new board, and also the quantization. TensorFlow for microcontroller, which is also called TensorFlow Lite. So we are already supporting it. I think it's supported since the version. It's not the version you have, but the next version. Because for this workshop, we have frozen a version just to be sure that everything is running well and so on. But if you are taking the next version, so it's supporting this one, which is already available, the current one, yes. Yeah. And we are additionally layers, so we are supporting always more and more layer. Okay? And the next step is in 2020 is to support the ONNX structure. What is ONNX? It's everything except Google. So Google is generating a specific format in this case, and all other, I would say, company are also generating in the ONNX. It's a unified format for this kind of stuff. And we will support it in 2020 because it will be defined, finally defined in 2000, or finalized, I would say, in 2020. It's the only reason. Okay, these are the roadmap for the AI, Cube.AI. And again, what I explained is not only, it's a toolbox, what we are proposing. So that means you have some tools, software tools, hardware tools in this case. You have a community, and for all the function pack, and we are using one function pack today. So this is an audio slang classification, or this is a sensor pack, let's say. We are providing the audio and the motion example. So almost everything is inside the package you have. So the goal is, if you want to start from scratch, you can, reuse the package, and then step by step, over the 5 steps, redo it by yourself. This is our goal. in order to get a little bit confidence and then to develop your own neural network. So you are providing everything in source code in this case. And you have dedicated community. This is the package, the FP package, so AI sensing package we are providing. So inside this package, downloaded package, you will find documentation and all the material you need in order to develop from scratch the neural network. Okay, this is a pack scope. So it's educational, so it's for you to learn from it. It's a simple based development board, and this is something you can do at home in this case. And it's including power optimization, because if you are using microcontroller, it's maybe because of the price, but it's also because of the optimize ultra low power capability. I mean, for neural network, it's quite important. These are the sensing. The only, I would say, library which is in a binary and not open is the AI NN library from ST in this case. Why? Because, okay, you can imagine that it's a Cortex M4, M7, so you have a lot of on the market, and we don't want to have, other people, using it. But this is the only thing which is, I would say, in binary. But normally, we should not have to, we just have to use it in this case, and we'll explain how. The rest is open, and this is all what the package is, offering to you. So firmware, on the air, and so on. So we are starting with the hardware, supporting different board. This is including the board you are using. And then we have the whole hardware abstraction layer, like we have in all STM32 in this case. In the middleware, we are proposing some pre-processing stuff. For the audio, we are proposing the audio pre-processing logmail. And for the accelerometer, the gravity and Rodriguez stuff, so we have some algorithm dedicated to what we are using in order to pre-filter or to pre-process the data. And then you have the standard package. Again, this is the example you have. So, and this is the example we are using. So there are different paths. The first path is in order to record new, because in your case, you will have everything open. So you have all the package, you have all the recorded information, and maybe your idea will be to optimize it. If you want to optimize it, you can. No problem, because everything is open. You will just have to use the embedded, audio board you have, record it using the apps, save it on the SD card or somewhere, else, and then you will have to relearn the system. So you have this path. And the second path is what we have done this morning, is the application itself. So this is using the application. So you are inside, outside, or in the car, and it will be detected automatically. This is for the audio scene classification. With the same sensor and the same board and the same application, we also have a human activity recognition based on accelerometer. So and what are we doing? It's a 5-class package in this case. So what we are detecting if you are doing nothing, so standing, if you are walking, running, or bicycling, or in the car. Just using the same. And you can have both running at the same time. With the new package, you can have the board, and you can detect both at the same time. If you are in the car, so it will detect in the car and in the running car, in this case. Okay, so just to finish, the Cube.AI, okay, this is the tools, and again, it's doing 5% of the job, the final job, because the big part of the job from the 5 steps are before, the first, the second, and the third step. These are the big part of the job for this. But nevertheless, so with the program and all the stuff, so we are normally proposing something ecosystem in order to develop, properly a neural network on the STM32.